reminding me. I don't know why I keep. Okay, so I want to parameterize this line segment. Basically, what happens is I will take a point. Imagine you take a point P with coordinates x, y, anywhere on this line segment, like this. And yeah, what happens now is that we have two vectors. Consider these two vectors. This one, yeah, let's say we call it A, and this one we will call it B. Yeah, two vectors A and B. You can see, of course, these two vectors are parallel to each other. They're exactly in the same direction. Therefore, the vector B, or I would say the vector A, I will use the vector A is going to be a constant multiplied by a vector B, multiplied by the vector B, because A is parallel to B. Therefore, we have this. Okay, sorry. Now, if you look at the vector A, of course, the vector A will be x minus x1 and y minus y1. Yeah, y minus y1. This vector is going to be equal to t times the vector b. What is the vector b? What are the components of the vector b? Which is, just 1 second, because I have to answer this phone. Hello? Alaikum salam. Right, I'm in class now. Can you maybe at 10 o'clock or at 10 o'clock, please? I'm finishing, sorry, at 12 o'clock. I finished the class at 2. Yes, please. Thank you. Thank you. Sure. Thank you. Right. Sorry. Okay. So B, the vector B. So what do you think the vector B is then, guys? What do you think? The vector B, which is the vector PQ, it's going to be. Yep. The vector B is the vector from P to Q, like this. So it's the coordinates of Q minus the coordinates of P. Therefore, yes, thank you, x2 minus x1, and also y2 minus y1. So from here, we get actually two equations. We get x minus x1 equal to, yeah, let me just, yeah, t times x2 minus x1, like this. And we also get y minus y1 equal to t times y2 minus y1, like that. And the value of t will go from 0 to 1, like this. So in the end, we can change a little bit these equations if we want. We can take x1 to the other side. So it will be x equal to t multiplied by x2 minus x1 plus x1. And the y will be t multiplied by y2 minus y1 plus y1, and the value of t will be from 0 to 1. And that is the way we parameterize, we find parametric equations of a line segment which goes from x1, y1 to x2, y2. Now, why exactly is t between 0 and 1? Well, if you take, for example, if you go here and you take the value t equal to 0 and you substitute in this equation, you will get the point x will be just x1 and y will be y1. So we are starting when t equal to 0, we are at this point here. T equal to 0, we substitute in the equation, we get exactly the point x1, y1. Now, if you put t equal to 1 in the parametric equations, we can see what will happen. When t is equal to 1, then if this number here, t, is 1, you can see that x1 minus x1 plus x1, so you will get x2, the point x2, and the value of y will be y2. So therefore, and any other t you substitute in the equation will give you a point on the line segment like this. So t equal half will give you a point, t equal 1/4 will give you another point, and so on. So this is what you see here in this blue thing here is the way you parameterize. T is, you can think of t as a time, yes, you can think of t as a time. So think about it. So it's t multiplied by x2 minus x1 plus x1, and then y equal t y2 minus y1 plus y1. Or these or these are, they're exactly the same, identical. So we can apply this here. Yeah. So this is x1 y1, and this is x2 y2. So the parametric equations will be x equal t multiplied by, what do you think? x2 minus x1, yeah? What is x2 minus x1 in this case? x2 minus x1. What is the x2? It's, yeah, x2 minus x1. What is it in this situation, in this example? Yeah, it's 3, yeah? It's 3, and then plus x1, which is 1, like this. And y will be t multiplied by 7 minus 2, which is 5, plus 2 this time, and t from 0 to 1. So therefore, you can say x will be 3t plus 1, y will be 5t plus 2, and t between 0 and 1. These are the parametric equation of the line segment from 1, 2 to 4, 7. We can check that if you, in this equation, if you take t equals 0, you should find the first point. Yeah. See, if you take t equals 0 here, x will be 1, and the y will be 2, which is exactly the first point. And if t is 1, and you substitute, what point are we getting to get? If we put t equal 1 in the parametric equations, we'll get to 0.47. You can check that. 3 times 1 plus 1, so you get 4. And then 5 times 1 plus 2 is 7. So we're getting the 0.7. Any other value, I can take t equals, say, 0.5. I will get a point somewhere on the line segment, somewhere on the line. Yeah. T equals 0.5 will be exactly the middle. It will give us the middle. Yeah. At t equals 0, we are here. At t equal 1, we are here. At t equal half, we are probably in the middle. And then various t's will give you different points on the line segment from P to Q, like this. If we call this P and this Q, like that. So just use the formula, just use the rule. It's up to you. You can use these. Yeah, these are fine. Yeah, or the other one over there. We can, both of them will be fine. Okay. Right. So that's how you parameterize a line segment. Now, how do we find parametric equations of an XY equation? This means y is equal to x squared from minus 1 to the 0.39. I think I already did an example like this. Yes, it should be between them. Yes, indeed. So when you have y equal x squared from the point minus 1 to the 0.39, these are the xy equations, xy equation. Then the parametric equation, in this case, parametric equation will be x equal. Do you remember how we parameterize something like this? I think I gave you right at the beginning of this section, I gave you an example like this where we have a parabola. This is a piece of a parabola, y equal x squared, from one point to another point. What are the parametric equations? Do you remember how we find the parameter? Yes, thank you, Nora. Yeah. X will be t. Yeah, x will be t. Then that means y will be t squared. Great, thank you very much. Yes. So y will be t squared, and then t. Yeah, you always parametric equations often have this value of t from where to where, from where. So what is the interval for t between what value and what value? For that, you need to look here. You need to look at these 2 points. We're looking at the parabola only from this point to this point. Now, the first point, what is the value of x in the first point? The first point, x is equal to what? -1. So that will be the start for t, because t, remember, is the same as x. So t will go from -1 to what? Look at this at the other point. Yeah, 3. That's it. So t will be from -1 to 3, and these are the parametric equations of this piece of parabola. These are the xy equations, and these are the parametric equations. They describe exactly the same thing, but in different ways. Yeah. So okay, so that is fairly simple to find parametric equations like that. Now, another last example here. Maybe we give you parametric equations and we want to sketch this curve. What is it exactly? Is it a line? Is it a circle? Is it a parabola? And so on. So what we have here is, so the A is x is equal to t minus 1, and y is t squared minus 2. I want to graph this. The way you do that is actually to find an xy equation. So what we'll do is we will get the t from the first equation and then substitute it into the second. So what is t from the first equation? Girls, what is t from the first? X plus 1. Thank you, Aisha. Yes, x plus 1. And then we substitute into the y. So it's going to be x plus 1 squared plus 2. Now this is then the equation, the xy equation of this curve. Now, can you recognize this? What is -2? Yes, thank you. Yes, -2. Can you recognize what this what is this curve here? This equation, does it ring a bell? Do you remember what sort of equation would that be? What sort of graph you will get from this equation? It's a parabola, yes. This is a parabola. In general, let me just mention something here, girls. Y equal ax squared plus bx plus c is a parabola, but also this equation, sometimes you'll find it in this form. X minus h squared plus k. Both of these type of equations are parabolas. They are parabolas. It's a parabola, and of course a parabola can go up or down, yeah? Not in the origin, exactly, yes. So it can go up if A is positive, it will go down if A is negative. This point here is what is called the vertex of the parabola, yeah? The vertex of the parabola is, if you have an equation like this, the vertex is exactly HK. Is the coordinates of the vertex are at the point HK. So this then is a parabola which opens up because A is positive here, and with a vertex at, what is its vertex? What is the vertex of this? -1, yeah, -1, -2. Thank you very much indeed. After that, we can graph without any problem. So we can then say, okay, our parabola is the following: -1, -2 is down here, and it will open up. And actually, when x is 0, the value of y is -1, so it goes through the points like this, and we have got our parabola, nice and easy, -2, -1, and we have the parabola like that. So the general idea is that if you have parametric equations and you want to graph, you want to sketch the graph, then you need to find the xy equation. You need to eliminate t, get t, maybe from the first equation or from the second, it doesn't matter. Sometimes it's easier to use the second one. So get t in terms of the other variable, and then substitute in the second equation, and then you will see what happens. Okay, so that's basically what this section is about. I want to do some examples, obviously, some of these exercises, just to make sure we're okay. Sketch the plane curve defined by this. Well, I think we did something like this. So do you know how we did this thing? Anyone remembers? X over 2, yeah? So we get x over 2 is the cosine t, and y over 3 is the sine t. And then we use the trigonometric identity. So this means x over 2 squared plus y over 3 squared is going to be 1. And then that means x squared over 4 plus y squared over 9 is equal to 1. So this is the xy equation. So we changed the parametric equations. We changed the parametric equations here into xy equation. Now, what is this shape? What is the graph of this xy equation? It's an ellipse, yes? It's an ellipse. In general, by the way, girls, in this kind of equation, if these two numbers are different, you can see here 2 and 3, they are different. It's going to be an ellipse. What happens if they are the same? If you have 2, 2, for example, what will be the shape of the curve? It's a circle, exactly. If the two numbers are the same, you will get a circle. If the two numbers are different, it will be an ellipse. And of course, you want to graph this ellipse. It's centered at the 0, 0. You can see what happens on the axis. For example, when x is 0, you will get y squared over 9 equal to 1, which means y is plus or minus 3. So that means our ellipse goes through these 2 points, minus 3 and 3. When y is 0 and you substitute in the equation, you will see that you will get x squared over 4 is 1. That means x is, what is the value of x this time? If x squared over 4 is 1, that means x will be what? Help me here, girl. Plus or minus? Not 4, plus or minus 2, yes. Plus or minus 2. X squared is equal to 4, basically. Therefore, yes, it's going to be plus or minus 2. So it will go through this point 2, and it will go through this point minus 2. So you will get a shape which is like this, yeah? Like that. Okay, so that's basically the curve. You can do the same with the part B. Sorry, this is 1. Yeah, this is question 1. Question 2. I think we did an example like this before, sir. You may remember what we did here. What did we do? What was the first thing? I'll give you. So what was the thing? X. What do we do here? Yeah, x minus 1. You take minus 1 there and then divide by 2, basically. So you will have x minus 1 over 2, all of this squared, plus what? Plus y, yeah, y plus 2 over 2 squared equal to 1, like this. So that means x minus 1 squared over 4 plus y plus 2 squared over 4 is equal to 1. So we will have x minus 1 squared plus y plus 2 squared is equal to 4. And what is this equation? What? I multiply both sides by 4, yeah? So this 2 to the power of 2 is 4, so we have that. Then multiply both sides by 4, multiply everything by 4. So you get 4 and 4 will cancel. Yeah, it's like putting 4 here, 4 here, and 4 here. Then you will cancel the 4s and you get this, which is a circle. Yeah, it's a circle. So now I can say this is a circle. And of course, we need to say what is the center of the circle? What is its center? Yeah, 1 minus 2. Very good, thank you. 1 minus 2. And what is its radius? What is the radius of the circle? Because we need we need this. It's going to be square root of 4. Yeah, square root of 4, which is equal to 2. That's it, like that. So once we have this, of course, we can graph. We have no problem in graphing after that. We can, yeah, sketch the graph. We can do it. So the center is 1 minus 2, so it's 1 and then minus 2, yeah, like this. And then, yeah, the circle of radius 2, so it's going to be a bit like this. Centered at 1 minus 2. Okay, yeah, like this. All right, now 3 is a similar thing. So what we have here is, okay, I can get, yeah, I can get t from the first equation. So t from the first equation will be x plus 1 divided by 2. And then we substitute this into the second equation. So we get y equal 3 times x plus 1 over 2. So it's going to be 3 over 2 times x plus 1. So we get y equal 3 over 2x plus 3 over 2 as the xy equation. All right, so what shape is this? If you have an equation 3 over 2x plus 3 over 2, what sort of line? It's a straight line, yes. So this is a line, and you can graph it by just finding 2 points, yeah, x, y, 2 points, and then you can graph that without too many problems. Okay, great. Same thing here. I will leave you these. You can try them, check them, see what happens. General idea is always to find t from one equation and substitute it. Now, find parametric equation for the line segment. So if we use the rule I gave you before, for a line segment, x will be, you remember what we did? The beginning of today's class, a line segment, yes? So from one point to another point, parametric equations. So yes, so what you do is this minus this, so it will give you 3t, yeah, plus 0. Thank you, Shama, yes, plus 0. So let's write it like this for the moment. And the y, yeah, the y will be 4 minus 1, yeah, 4 minus 1, so that will again be a 3t, but this time plus 1, very good. And t goes from 0 to 1, halas, that's it. Now, of course, we can cancel the plus 0, so we get our parametric equations without any problem. Are we okay with this? Yeah? Yeah. So just use the rule for parametrizing a line segment from one point to another. Again, this one we just did, I think, a moment ago, how to parameterize a portion or a piece of a curve like this. So what will be the parametric equations here? Come on, girls, what will be the parametric equations? X equal t, so x equal t, yeah. And then y will be, okay, so t squared plus 1, great, yeah, t squared plus 1, and t going from 1 to 2. That's it, that's it. Thank you. So that is the parameterization of this piece of parabola. Yeah, we can leave that. Um, okay. All right. Okay, finally, let me perhaps do this 37, which is, we have two um, curves. Yeah, one is given by this parameterization and the other one by this parameterization. And I want to know, this one is a parabola, by the way. This is a parabola, and this is a straight line. And I want to know, I want to find their intersection points, the intersection point. Can you hear me now? I think you can now, yes? Okay, thank you. All right, so what we're going to do is, so the parameter here is t, yeah? The parameter here is s, so it's okay. Parameter, you can use any letter. So because x is t and also equal to 1 plus s, so I must have this. So that's our first equation. The second equation is t squared minus 1 must also be equal to what? What do you think I should write? 4 minus s. Yes, thank you. 4 minus s. So I really need to solve these two equations together. So there are many ways of doing that. One way is perhaps just to add these two equations, because when we add them, we, of course, the s plus s and minus s will cancel. So we're going to get t squared plus t minus 1 on one side. And what are we getting on the other side? Equal to 5. Yes, equal to 5. So that means now we have the following equation: t squared plus t minus 6 is equal to 0, which will give us two values of t. Yeah, t1 is, so you want to solve this, you can use your calculator if you want, mod 5.3. Yeah, if you use mod 5.3, you will see that you will get 2, and the other value is equal to 3. Yes, exactly. Now, so basically what happens here when T1 is 2, so that means I can also get S, yes? So S, if I substitute perhaps in the first equation, yeah, S is T minus 1, so S is 1. And for this one,
Doctor, it's minus 3, not 3.
again, T minus 1, yeah, which is 2, like this. So let's see now. So basically what we are getting is, yeah, when t1 is equal to 2, what is the point we are getting on the first in this curve here? So you substitute here. Okay. All right. Sorry, is it? It's -3. Yes, -3. Yeah, -3. Thank you. Yeah. I was, yeah. So -3. So, yeah. So it's -4 then, yeah? Okay. Okay, so when t1 is 2, so we're going to substitute in the first curve. So we're going to get 2 and 3, the point 2, 3. And s is equal to 1 on the second curve. So s is 1. And also you can see that we're going to get the point 2, 3. So the first intersection point is the point 2, 3. So these curves cut, they intersect at 2, 3. Then there is also the other situation where T2 is -3 and S2 is -4. And we substitute in the first curve. So what do we get if we substitute in the curve with the T? So what point are we getting then? Did I lose you here? Are you lost? Or are you still following? Yes, so when T2 is equal to -3, so we go to the first, these equations, yeah? These are the parametric equations with a T. So what point are we going to get if you put T equal -3 there? So you will get the point -3 and Y will be 8, exactly, yeah. And S2 equal to -4 in the second equation now, yeah, you will also see that you will get the point -3, 8. Okay, so in the end, what is this telling us? What is this telling us about these two curves? We have a parabola and we have a line, yeah, a line. How many intersection points are we getting? These two curves, yes, these two curves are cutting each other at two intersection points like this. The first one is 2, 3, yeah, is 2, 3, and the second point of intersection is -3, 8, like that, yeah. So it's kind of, no, maybe it will be the other way around. Okay. Anyway, it's yeah, it's going to be going the other side, perhaps 2, 3, and then so -3, 8, and 2, 3. Yes. So this point will be a -2, 3, and this point will be a -3, 8. No. Okay. Anyway, I leave it. I will not graph this. It's okay. We can graph this if we want, but that's not an issue. Oh, why is it 8? So let's see. You mean this 8 here or this 8? Is that what you mean? Yes. Remember, we have these equations. X is equal to t, y is t squared minus 1. So if t is 3, substitute here, yeah, t is equal to, sorry, minus 3. T is minus 3, yeah. Substitute here, what will you get? X equal minus 3, there, yeah. And y will be minus 3 squared, which is 9, minus the 1, which will give you 8, like this. So it's going to be the point minus 3, 8. And when t is minus 3, s is minus 4. So you can also check that when s is minus 4 and you substitute in the second set of equations, you will get also minus 3, 8. So two intersection points which are 2, 3 and minus 3, 8. Yeah, that's the final conclusion of this work. These two curves will cut at the 2 points. All right, I will stop here this section. We're done. Yes, I think you can skip by S. You can just find the T's. It will work. Yeah. So the part where I'm finding S may not be necessary. I did it, but it may not be necessary. You can just work with T, solve, find the T, the two values of T, and then substitute, and that should give you the answer. But I'm just checking that if I find S and I substitute, I'm getting also exactly the same points. Yeah, I'm getting the same points like that. So good question, Salha. Yes. You can just find the T and that will be fine too. Okay, so let me, are we okay with this? Shall I? Yeah, all right. Okay, so a bit of a strange section this. So I will close it and we will go back to our vectors and planes and lines in space. So just give me 2-3 minutes. I want to close this and bring up the next section. Okay, just 1 minute.